Okay, a lift of mass 600 kilograms is raised and lowered by means of a cable attached to its top. When carrying passengers with a total mass of 400 kilograms, the lift accelerates uniformly from rest to 2 meters per second in 5 meters. So then we've got to find each of these then. So sort of force diagram here, yeah, with the cable pulling the lift up or lowering it down. Okay, see there's going to be tension in that cable, so that's the sort of force there that is applied to the lift. And of course then the lift itself then has a weight, yeah. Now we've got to be careful when it comes to weight, because it says the lift of the mass is 600 kilograms. The mass of the lift is 600 kilograms, but also obviously then there's going to be passengers in there as well, people in there. And they've got a total mass of 400 kilograms, so you've got to think of the whole overall mass to be 1,000, yeah, but when you add those two, 1,000 kilograms, so that means then the weight will be the mass times g, mass times gravity, so it'll be 1,000 g. Okay, but in A it just says find the magnitude of acceleration. Okay, and because it accelerates uniformly, of course we can use the equations of motion, right, to solve that. Okay, and let's see what we know. It says it accelerates uniformly from rest, so that means the initial speed is 0 to 2 meters per second. So then the sort of final speed is 2. So we know the initial speed 0, final speed 2 in 5 meters. So we also know then the displacement. Okay, so we know all them. We don't know time, but that doesn't matter. Okay, we want to find acceleration, and we can do it using an equation of motion, applying these values here. So the one I would apply is v squared is u squared plus 2as. Okay, so put the numbers in. The v, the speed it gets to is 2, so it'll be 2 squared. The u is 0. And then 2as. Well, I don't know what a is, but I know s is 5. So we got 4 there. That's 0. And then times these. 2 times 5 is 10a. So then 4 is 10a. Which means then a will be 4 divided by 10, which is 0.4 meters per second squared. Okay. So then in B then we've got to find the tension in the cable if motion is vertically upwards. So if it's vertically upwards, it's going to be accelerating that way. Okay. Yeah, so when we apply Newton's second law of motion, okay, well the greater force is going to be the tension. Okay. Take away then the resistant force. So the weight of the lift is actually resisting, isn't it? It's pulling it down when we want to go up. Okay. Equals to then the mass. So resultant force is mass times then the acceleration, which is 0.4. So it's a case then of putting g in to be 9.8. That's going to be 400. So then t will be 400 plus then, well, 1,000 times 9.8 is 9,800. So we get t to be 10,200 newtons. Now, of course, if it's then in C, it says the tension in the cable if motion is vertically downwards. So we're accelerating downwards. Still the same value, 0.4. If it's going downwards, that means this weight overcomes the tension. So the weight is stronger than the tension force here in order for it to go down. Okay, so there's a bit more slack in that cable. So we've got 1,000 G, take away T. That's going to be the resultant force. Okay, so notice the reverse of what we had before. It's sort of like back to front. Okay, because this time when it's going down, this, as I said, this weight is greater than the tension. There's more slack in that cable, so it's pulling it down. That's greater. And of course, completing this resultant force is the mass, which is 1,000 times then the acceleration, which is 0.4. So we've seen this before. 1,000 then times 9.8, take away t, and 1,000 times 0.4 is 400. So then we've got here 9,800. Take away, we'll swap them. Take that 400 over, and take the minus t over. So that means t then is equal to 9,400 newtons. So you can see then the difference in tensions If it's going upwards, that's the tension. If it's going down, that's the tension, and you'd expect it to be less, wouldn't you? Okay, or you'd expect it to be more if it's trying to pull the lift upwards.